Hello everyone. In today's lecture, we are going to understand the concept of differentiation. So what is differentiation? So differentiation is the process of finding out the slope or the gradient of a curve at any point. So if we have a curve and there's a point P which is x and y, the process of finding out the slope of the curve at this point P is known as differentiation. Now, in order to understand this concept of differentiation, how to find out the slope of the curve at any point, we need to understand three concepts. The first concept is what is the gradient of a straight line. The second is the concept of limits. And the third one is the gradient of what do you mean by the gradient of a curve at any point P, x and y. Let's take the first one. Gradient of a straight line. We already know that the equation of a straight line is y equal to mx plus c. So if we have a straight line and there is a point A and there is a point B, the equation of the line is y equal to mx plus c. Now, what is this m? This m is the slope of this line AB. Now, we know from our earlier mathematics that this slope of the line MAB is nothing but the difference of the y coordinates and upon the difference of the x coordinates. So if we have a point A which is x1 and y1 and a point B which is x2 and y2, the slope of this line is the difference of the y coordinates upon the difference of the x coordinates. What does it mean? It means that if we were to draw a horizontal line here and a vertical line here, it is this rise upon the displacement along the x-axis. So if this is the x-axis and this is the y-axis, if this is the y-axis, that means this displacement, how much A is displaced towards B along the y-axis and how much point B is from A along the x-axis. That's what the concept of this is. y2 minus y1 is the displacement on the y-axis and upon the displacement on the x-axis. Okay, in other words, it means what? How much B is away from A along the y-axis and how much B is away from A along the x-axis. Okay, so this is the concept of the gradient of a straight line that we have studied in earlier classes. One more point to remember when we are finding out the gradient of a straight line AB is that this gradient that we have found out, that is y2 minus y1 upon x2 minus x1, is remaining the same on all the points of the straight line. So if we were to take another point C and D and find out the gradient, we would arrive at the same result as MAB. So the gradient of a straight line is the same at all points on the straight line. In other words, the gradient of a straight line is constant. Okay. Now we will come to the concept of limits. So let's understand the concept of limits. So firstly, we will be needing this formula of a straight line when we are deriving the formula for differentiation. So this is a very important one, and we will be taking the concept of the gradient of a straight line into the concept of differentiation when we come to the process of finding out the slope of a curve at any point P. Okay, so now let's understand the concept of limits. What is the limit? Limit is if we have any curve, let's say a function of x, and we are to find out the limit at a point P, So limit means what? What is the limiting value of this function when it is almost close to P from the right hand side and from the left hand side, but not at the point P. Okay, what do you mean by this? Let's take a point somewhere here and find out the value of the function. let's say it is 12, and this P is a point 2, 5, let's say. So we want to find out the limit at the point P2. So let's take any point here, y, which is 12, let's say. Any point here which is away from the point P, and plug in the value of P into this function, and let's say we get a value of 12. We come closer from the right hand side towards this point P. Let's take another value which is closer to this and nearer to P. Let's say we get the value 11. Still, let's come closer. We get the value 9, 7, and so on, until we get to a point which is very, very close to 2. Let's take a point 2.00001. We find that the value of function is something, value of the function is, let's say, 5.0005, let's say. Okay. Now, let's take a point P. Let's take another point which is to the left of the point P, and find out the value of this function. So maybe it is at a point 0. Maybe we get the value 0 first of all. Then we take another point which is still closer to 2. Okay, the value of x is closer to. We get the value of the function as, say, let's say 1. Still closer we get 3. Still closer we get 4. Until we get to a point which is very, very close to the point 2. Let's say 1.9999. So if you plug in the value of 1.9999 into the function, we will get a value, let's say 4.99995, let's say. Now, as we see that when we are approaching from the right hand side, we are reaching the value of 5, and when we are approaching from the left hand side, we are also reaching the value of 5. So we say that the limit of this function at x equal to 2 is 5. So this is the concept of a limit. Okay. So now let's understand point number 3. What do you mean by the gradient of a curve at any point x and y? So if we have a curve like this, we know that gradient of a straight line is constant on all points of the line. If we have a point A and we were to find out the gradient of the curve at this point, it is definitely different from the gradient of the curve at this point. The gradient at this point, you will see, is much more steeper. The gradient here is much more steeper than at A. Now, so what do you mean by the gradient of a curve at a point? So the gradient of a curve at a point is nothing but the gradient of the tangent to the curve at that point. So if we have a point A, and if you are to draw a tangent at this point, then the gradient of this tangent is the gradient of the curve at this point A. The gradient of the curve at the point P is the gradient of the tangent at this point P. What do you mean by the tangent? What do you mean by the tangent? So a tangent is a line that touches the curve at that point at only one point. So if we have this point A, and if we draw a line like this, is this a tangent? No, because it's touching the curve at these 2 points. Okay, so a tangent is a line which touches the curve at only one point. Okay, so what do you mean by the gradient of a curve at the point Pxy? It is nothing but the gradient of the tangent at this point P. So this is the tangent. Okay, so if we were to find out the differentiation of any function y is equal to a function of x at any point P having the coordinates xy, the process of finding out differentiation at this point is finding out the gradient of the tangent to the curve at this point. So this is in effect the concept of differentiation and the related concepts of gradient of a straight line, the concept of limits, and the gradient of a curve at the point pxy. So in the next lecture, we will be taking some algebraic expressions to arrive at the formula for differentiation. So meet you in the next lecture. Thanks for watching. So I hope you have understood now the concept of differentiation. That is the process of finding out the slope or the gradient of the curve at any point P, and the concept of the gradient of a straight line, the concept of limits, and the gradient of a curve. So to summarize, in this lecture, we have seen what differentiation is, what the gradient of a straight line is, the concept of limits, okay, and what you mean by the gradient of a curve at any point pxy, and what is a tangent, okay. So in the next lecture, I'll be taking differentiation in more details and the algebraic method of finding out the differentiation or the differential or the derivative of any function fx at a point pxy by taking some algebraic expressions and arriving at the formula for differentiation. Till we meet in the next lecture, thanks for watching.